When you hear the word regression, all we're talking about is if two things are related, if a relationship exists, like between height and shoe size, the temperature outside in the winter and your heating bill, or the number of pets you have and the color of your hair. By the way, that'd be no relationship there. And so we talk about the correlation between two variables. And that has to do with how strong and in what direction there is a relationship. And we're going to be talking about all relationships that are straight lines. So when you look at these three scatter plots, you'll notice that we're not going to get a perfectly straight line, but it's going to be an approximately straight line. So from left to right, these dots are all going up. So this correlation is positive. These dots from left to right are all going down, so this correlation is negative. These dots are all over the place. We have no idea where they're going from left to right, so there is no correlation, or none. The stronger the correlation, the closer your dots are to that line. So if we have something like that, we can draw a line of best fit, like I was doing, or the fancy word for it is a regression equation. And then we can use that line to make future predictions. Because as humans, all we can do is collect data and then use it to figure out things that we don't know. So we're going to be looking at a lot of real-life situations. So somebody thought it'd be really interesting to see if there was a relationship in temperature between Akron, Ohio and Wellington, New Zealand, because they're about the same distance from the equator. So is there a correlation between those two cities? The first thing you'll do is make a scatter plot of the temperature data. So we will put the temperature for Akron on the x-axis, the temperature in Wellington on the y-axis, label the x and y axes accordingly. For x and y, here's Wellington, this is Akron, it got cut off. And this is the temperature in Fahrenheit. So when it was 33 degrees in Akron, it was 67 degrees in Wellington. So the first dot plotted is 3367. That's the one right there. The next one was 3767. So they went 37 over on the Akron side and then up 67 on the Wellington side. And so all of these dots have been plotted for you. So you're welcome. Next we will identify the correlation. So what does it look like is happening to those dots as you move from left to right? Well, it looks like they are going down. So we say this is a negative correlation. Or you could write negative correlation. Next, we will sketch a line of best fit. Try doing this as straight as you possibly can with an approximately equal number of dots above and below the line. So let's see how I do. That's not too bad. That's without a straight edge, so maybe yours will be better. So we've done that, and now we will find the equation of that line. So we need the slope, and we need the y-intercept. Well, see how I made my line go all the way across the graph, and I even made it cross that y-axis? We can use that dot right there as an approximate value for the y-intercept. So if this is 70 right here, then that next dash it looks like will be about 75. So I'm going to use 75 for my b value for the y-intercept. And now we just need to find the slope. So let's pick two good points that it looks like my line is going through. And it's not going to be perfect. How about this one right there? We'll say that's pretty close to the crosshairs on the graph. And how about this one right here? So this dot is at 35 on the x, if you look down here, and it is 70 for the y. This dot right here looks like it's 70 over on the x-axis and 55 up on the y. So let's plug those into the slope equation. So we'll take the y's and subtract them. So I'm going to label, like I told you to do, x1, y1, x2, y2. So we'll do 55 minus 70, and then we'll subtract the x's. We'll do 70 minus 35. So on top, we're going to get negative 15, and on the bottom, we will get positive 35. We could reduce that and say it's about negative 3/7, or you could even turn it into a decimal, which rounds to about negative 0.43. When we use these real-life situations, we'll use decimals for slope, and that's okay. So let's write our equation. Y equals our slope, negative 0.43, and then the x, and then our y-intercept, which was up 75. So there's one example of a line of best fit. If you look in the book's answer was similar. Theirs was negative 0.36x plus 81, because our lines were a little bit different. So we're going to learn how to have the calculator draw lines for us so that everybody's not just eyeballing their own straight lines of best fit through data. That way we all can come up with similar equations. So how do you really know if you have a good line? Or if the relationship between your data is actually one that's worth looking at? We have this thing called the correlation coefficient. It is called an R value. The R stands for regression, because that's what we're studying, and it's a measure of how well a straight line fits a data set. It is always a number in between -1 and +1. So let's look at this first scatter plot right here. This is a pretty strong negative correlation. Those dots are all pretty close to that line that I just drew. So we would say that R value is approximately, it's negative because this correlation is going down, we'd say that's approximately maybe 0.95. A perfectly straight line, where all of the dots are perfectly on the line, would be like that. So anything that's close would be a decimal very close to -1. These dots are all kind of moving in the downward direction, but they're really spread out. So we would say this had an R value of maybe approximately -0.6. So it's kind of negative, but it's kind of all over the place. This one for sure is all over the place. So when there's no correlation, the R value is 0. Next, we have a fairly weak positive correlation. So we say the R value is approximately +0.6, because it's kind of okay. These dots over here are pretty dang close to that line. So we'd say, and they're going up, so it'd be a positive decimal that's pretty close to 1. And then again, the only way you have an R value that is exactly 1 would be a line where all of the dots are right on it. Alright, so those are the options. The closer your R value is to +1 or to -1, the closer your dots are and the better the fit the line. The closer your R value is to 0, either on the positive or negative side, the worse your correlation is, because those dots just get so spread out. At this point in the notes, you do need to have a graphing calculator. So if you are doing this at home, you are welcome to watch the video through, but you will need to practice this either in class or with your own graphing calculator if you have it as you're doing it. So make sure you have that for the next page. So hopefully you have your calculator, and everything we just did in example 1 drawing the scatter plot, making the line, finding the equation, and even finding the R value, the correlation coefficient, the calculator can do all of that for us. We just have to tell it what to do. So to start with, you have to tell the calculator that you want to know the R value. You want to know how good your correlation is. So to do that, and you only have to do this one time, once you know that it's turned on, you're going to press second and 0, scroll all the way down till you see that picture right there, and press enter twice. It'll say done on your calculator when it's all done. Now you'll be able to use that R value. What would some good examples of R values be? Well, I just mentioned it in the previous page. So let's have this example walk us through the calculator instructions. There is a relationship, and we know it, anthropologists know this, between the height and the length of a woman's humerus bone, which is between your elbow and your shoulder, to estimate a woman's height. So you're probably already thinking, yeah, the longer a woman's humerus bone, the taller the woman probably is. So here's some data that's collected. This is in centimeters. Since this is the first variable listed, it will be our x. This one will be the y. And the first job is to make a scatter plot of the data. Well, we're going to tell the calculator to do that. So first we have to, before we see the scatter plot, we have to put all of this into the calculator. So here's how we enter a table. You press Stat and option 1 for edit, and then pick enter. All of your x's go in L1 right here, and all of your y's go in L2 right there. You just type the number, hit enter after each one until you have them all in, and then move over and enter them in L2. Sometimes there's already numbers in there. If you already see a whole bunch of numbers in L1 and L2, you can clear them out all at one time by doing this. Scroll up so you highlight the L1, press clear and enter, and then do the same thing with L2. So you can do that at the start of every problem when you want to clear out previous data. So once you have your lists filled in, all the x's in L1 and all the y's in L2, you want to see what your scatter plot looks like. So you have to turn the scatter plot on. So you press second and y equals, and your screen will look like this over here. You want to make sure that plot 1 is highlighted, so you just scroll on top of it and press enter one time. Make sure on is highlighted. Make sure that scatter plot is highlighted. That's the one we want. Your X list should be L1, your Y's should be in L2 like we just entered, and then those will be the dots you see on your graph. So once you have this whole screen all set up, then you can press zoom. It's right in the middle of your calculator screen underneath it. And then press 9, that is for stats, and then press enter. And then you should see a scatter plot of your table. Now that you have your data in the calculator, we need to do two things. We need to find the R value, the correlation coefficient, and we need to find the equation for the line of best fit, which is our regression equation. They're called the same thing, line of best fit regression equation. Then we're going to say what the slope means in the context of the problem. So the calculator will find both the R value and the regression equation all at the same time. We're killing two birds with one stone here. So press the Stat button, move the cursor over to the Calc menu. You can scroll down or you can just press the number 4 and hit enter twice. Once you hit enter twice, you're going to see a screen that looks like this. See how it says linear regression? It has our lovely y equals mx plus b, except for the m is an a. And you can see an r squared value, and you can see an r value. Don't worry about the r squared value, okay? We want the r value, so jot that down. You can just round it to 2 decimal places. So in this problem, our r value is 0.99. Assess that fit. That's a pretty strong positive correlation. So you can say strong positive. It's really close to 1. So it's a pretty good fit. Next, we need to copy down the equation. It tells us the equation is y equals ax plus b, so we just have to write down the numbers for a and b, where they go in that equation. So the number for a, right here, we're just going to use 2.75. We don't need to write all those decimals. Then we have the x, and now we're going to write the number for b. It is about 71.9, 71.97 is good. So plus 71.97. So there's the equation. There's our R value. And interpret the slope of the line. Well, it means that the longer the humerus bone, the taller the person. And it's a pretty good predictor. So now what we're going to do is tell the calculator to draw our line of best fit on our scatter plot, because you can't draw on the calculator. So press y equals. If there's anything in there in y1 or y2, clear it out. Type in your equation that we just wrote down. Type that in y1. And then press zoom and 9 and enter. And you'll just watch that calculator draw the line right through your scatter plot. If you'd like to trace some points, you can press the trace button and move the arrow left and right, and it will move along your graph. So just look at the screen on your calculator and it should work out. The last thing we'll do is use our equation in our graph to make a prediction. We want to predict the woman's height. Height was our y variable. The humerus length was our x variable. So we know that x equals 32. We could look at our graph and go to the x-axis and go over to where x is about 32, and then see where that is on the y-axis. So we could do it that way. Or, because we have a pretty simple equation here, we can plug the x value into our equation. So we'll take that 32, plug it in for x, and then calculate it out. So the equation was, I'm going to get rid of that y for a second, plus 71.97. So when you calculate that all out, it ends up being approximately 159.97, or about 160 centimeters is how tall a woman would be with a humerus that is 32 centimeters. So hopefully you can do all of that all by yourself with the calculator, and we'll practice more problems with other situations.